So this video is basically a how-to video for completing the 9 problems of the second simplification activity for rational expressions. In the numerator here we have a quadratic, and under formulas there is a manual way of setting up the two factors. You have to enter in the missing numbers, but again you're trying to get two things when you multiply them together to get x squared plus 12x plus 27. So I need 9 would be one of the numbers, and 3 would be the other number. One of the things I've suggested to you in class is that if you have an x plus 3 factor and you're trying to factor something, x plus 3 hopefully is one of the factors in the quadratic, so that when you place the x plus 3's on top of each other, since they have the same value, they become a value of 1, so they get canceled out. In the second problem, we definitely have x's on both sides of the subtraction sign. I recommend placing the x with the smaller exponent on top of the larger one. I find that the simplifying goes a lot easier. Same thing here. When I simplify the x divided by x squared, our rule is to subtract exponents to be 1 minus 2. So if I would put the x squared on top of the x, I would get a negative 1, but trying to put it back in the denominator, for example, to make it become x to the first power, the program doesn't like doing that. So my suggestion is, when you're simplifying fractions, always put the x, or whatever variable it is, with the smaller exponent on top of the larger one, and it will automatically subtract it and give you the positive exponent. In this third problem, we have two quadratics, so we're going to simplify both of them. And again, hopefully the goal is to get two factors, one in the numerator and one in the denominator, that are the same. So for the bottom one, we'd have x minus 6 and x plus 4. Recommend changes into subtraction. So again, hopefully up here, one of these factors is a factor of this quadratic, and actually is the x minus 6. So we're going to do x minus 6, and the other one's minus 5 or negative 5. So this gives me a value of 1. In problem 4, we have again x's on both sides of the subtraction sign. So if I place the x on top of the x squared, I'll factor out the x. Again, like a previous problem, if you place the x with the smaller exponent on top of the larger one, the x with the larger exponent, and they subtract the exponents, it will give you a positive answer. So that's x squared. All right, this one here, we talked about in class. The numerator is a difference of squares, and the answers are conjugates. Under formulas, they do have a difference of squares, but to be able to use that, you literally have to write the second term as a square. So you click on keyboard and click on the 49 and change that 49 to 7 squared. So both terms are squares. Then aggressive math will actually factor that as a pair of conjugates, so x plus 7, x minus 7. And then in the denominator, the two factors are x plus 7 is one of them, and then the other one is x plus 5. So using the manual factoring of quadratic, replacing the squares with 7 and 5. This would be our value of 1, so final answer is x minus 7 over x plus 5. Problem 6, we got two conjugates, so again, using the keyboard function, we're going to change the 36 to 6 squared, and the 81 to 9 squared. Using the difference of squares, we can factor those into their conjugates. In the denominator, the factors would be x minus 9 and minus 6. To get the middle term of negative 15 and a positive 54 as our product. So x minus 6 divided by itself is 1, and x minus 9 divided by itself is also 1. So final answer is x plus 6 times the quantity of x plus 9. All right, I'm going to focus on the bottom one first. We have a common factor of x. If you go larger to smaller, and then larger to smaller, because all three have factors of x in them, you'd get something like this. And you can simplify this. So one of the comments I made is that if you start with the small x, the x with the smallest exponent, and factor plot the x in both the other terms, you actually end up with a much nicer answer. So you don't have it, you can simplify it other than factoring the quadratic. So in the quadratic, you would have x plus 9 and x plus 1. In the numerator, we would have a x plus 9 and an x minus 4. So this would be our factor of 1. So this would be our final answer. In problem 8, I'm going to focus in on the quadratic. To get a 45 as a product and negative 14, both numbers are going to be negative, and that would be a negative 9 and a negative 5. So x minus negative 9 and x minus, or x minus 9 and x minus 5. So x minus 9 divided by itself is going to be the 1. 4 twelfths is going to be 1/3, and the x over x cubed, if I put the x with the small exponent on top of x, the bigger one, it'll give me a positive exponent, so it's going to be an exponent 2 there. So final answer is 1/3 x squared times quantity of x minus 5. And the last one, all three of these numbers have a factor of 3 in it. So again, I'm going to take the 3 as what I'm going to place on top of the other two factors to pull that out, the factor of 3 out. This is factorable, and you can get x minus 8 and x plus 4. So 15 divided by 3 is 5. X minus 8 divided by itself is 1. And so the final answer is 5x cubed over x plus 4. So hopefully, by going through the problems, if you made any mistakes, you're able to see what mistakes you made. I would encourage you to go back to the problems you have missed and try to see if you can complete the problems now after seeing them completed here. If you have any additional questions, let me know.